Welcome back to the channel, everyone. Jason, KO4TFE here today, back with you to continue work on our TR-35 kit build. Where we left off is we had just completed the top board. So today we're going to work on the lower board assembly, and just like you would expect, we have a parts kit that has everything nice in order, sealed in little individual compartments for us. So let's go ahead and get started without any further ado. So the first thing we want to do, we're going to solder our relay here. So this is a polarity mark, which is right there. I don't know if you can see that. Let's put this over here and see if we can. Yeah, there we go. So that you can see that line there. That mark needs to go towards the center of the board. And there's also a similar mark on the actual printed circuit board as well. So it's, this dude might be a little tough. He's kind of loose in there. One thing I made since the last video, this is I think a pretty cool little toy. It was one of the, it's one of the neatest 3D prints I've made so far. This all printed in one go on the bed and assembled and snapped together nicely with little C-clips. But basically, this your solder kind of goes through the middle here, and you tighten this ring until you get the right level of grip. But then this lets you actually slowly feed the solder out, gives you a little better control. I don't have great dexterity, it seems, anymore, and so being able to kind of control the solder in a more fine way, it's kind of cool. So I'm going to try this out. I haven't really used it yet. Let's I think I'm going to just advance a little of it here, get some on the tip, because what I want to do is tack weld this little relay into place. Just because he's kind of like I said, he's pretty loose, and there aren't, well, maybe I can bend some of these leads. Let's see if we can just kind of bend these leads. And that'll hold him good enough to get a little bit of solder on him. Let's just try this here. Alright, so now that that's there, I'm going to reheat it and get him nice and flush to the board. And I'm going to check this again just to make sure that I didn't do something stupid. So the line is towards the center of the board, which is what we want. So I'm going to go ahead and finish soldering him. This little tool, if you're interested, by the way, is called the solder scroll. You can find the print files on Thingiverse. I need to tighten this guy down a little bit, get a little more tension in there. But I think it was like maybe a 2-hour print or so, 2.5 hours or something like that. Printed really easily. And so far I'm liking it. It gives me a little bit more control over what I'm doing here. So let's finish up this side. Also kind of keeps the solder off your hands. Not something I'm terribly worried about. I've been soldering for a really long time. I've been an electronics technician at different points in my life, and this is leaded solder. Just to talk about solder for a minute, I use 6337. You can also use 6040, I think is pretty good. And I do use leaded solder. Lead-free solder is a huge pain to deal with, even in a professional setting, but with the tools that us typical amateurs have, it's really more trouble than it's worth. And you don't really get much benefit because we use such small amounts compared to like what an industrial facility would. And also, people are concerned about the fumes when you solder. And while they're not good, I mean, I have my fume extractor here. I'm sure you can hear it making lots of noise. When you are soldering, you're actually not heating up the solder beyond its vaporization point. So the fumes that you see are not lead fumes, they're actually fumes from the rosin and other compounds in the solder. And it's not good to breathe those either, but just to kind of allay your fears. And then lead does not absorb through your skin. So even if you're touching the lead solder, as long as you don't touch any of your mucous membranes, your eyes and nose, wash your hands really good before you eat or anything like that. Really, you're not going to have any problems with lead contamination or lead poisoning or anything like that. But again, this is 6337 leaded solder. It's rosin core, so there's some rosin-based flux in the center. So when you melt it, it actually kind of automatically adds some flux. You can also use a flux pen if you don't have the rosin core solder, but I like using this. This is a no clean solder, which there are a bunch of different types of, or excuse me, no clean flux, I mean, in the center. So there's water soluble flux, which is corrosive and must be cleaned off if you use it. This is no clean solder, meaning it's okay to leave on the board. It won't hurt anything, it's non-corrosive. It's made from basically rosin from trees. When we get into RF, there can sometimes be issues where at high frequencies the rosin can cause noise and things like that if it kind of bridges connections. So I do like to clean it, and I'll go over that process before I put these two board halves together, so that'll be another installment in this video. But anyway, you don't really have to clean it off. You can see it on the board, and actually I might be able to show you here. Yeah, you can kind of see that clear, shiny stuff around all the connections. That's the rosin, and it's, again, perfectly fine to leave it on the board like that. With this particular type, if you get a water-based or water-soluble flux, that's a different story, and you'll have to probably clean that off. This, with just some isopropyl alcohol and like a soft toothbrush, you can clean it off really nicely. You can also wash it with soap and water in the sink as long as you let it dry off really well. But anyway, like I said, we'll go over that in a different video when we get ready to put this stuff together. So now that we've got that guy in and we've looked at the leads there, it actually looks good. So I need to get my clippers so I can clip that off, and I'll be right back. Alright, so now we're going to use, you're going to install our diode here. So this is D5, which is probably going to be close to the power input, I would say, because this is a rectifier diode. Yeah, right here we go, D5. And then the band here, which is the positive end of the diode, is going to go towards the square hole here. And so current is going to flow in this direction in this diode. So, and let's get that guy good and flat and kind of see if we can pinch him in there with these leads. And this guy might actually be a little bit tough to get in there because he's got some thick leads and some big heavy duty pads here. Let's just apply a lot of heat and be patient. Let the pad and the component lead heat up together. And it'll tell us when it's ready. When the solder melts easily, when it's brought into the other side of the connection, you know you got it hot enough. Yeah, I gotta say, I think I'm really liking this little solder scroll. It's kind of a neat neat little toy. Or tool, I should say. It's not really a toy, it's very handy. Get these out of the way a little bit. Alright, let's inspect our leads here, see how well we did. It's pretty good, so let's go ahead and clip these guys off. Alright, making progress. So now we have a polyfuse. I like polyfuses. They're self-resettable fuses, so if there's an overcurrent situation, these will heat up and open the circuit to protect your radio. And then, once they cool off, they'll close back up, so you don't have to replace any fuses. Alright, so here's F1. These is no polarity on these either. And he says to fold this over into the footprint, so you can kind of see there's a circle on the schematic, or on the silk screen here. So before we solder this guy, we want to lay him down flat as I can get in there. And we're going to bend our leads down like we always do to hold him in place. And then we're just gonna, I need to get my vise out here, make my job a little bit easier. Alright, let's see what this guy looks like. Did we do a good job? I would say we did. Alright, let me get my vise out here. Apologize for the camera shake there. Alright, so this guy, because he has a B and C on him, I'm going to have to put him in sideways. Alright, so let's clip our leads here. Alright, so there's step 3 done. Let's see, what is step 4? We're going to do our DC power jack, which is J4. Over here on the edge of the board. So let's get our little parts bag here. Well, that's interesting. So are we missing? We might be actually missing a part here. So we had our relay, we had our diode, we had our polyfuse, and then here I have a potentiometer. So yeah, I believe we're missing our DC power jack. That's frustrating. The first little hiccup we've had here with this kit. I wonder, I don't think it's in the other kit, but let's check and see. So here's our parts kit for the connector. So we have our little LCD cover, some 3.5mm plugs, our switch covers, and our potentiometer knobs. Yeah, so there's no there's no power jack there. Well, that's frustrating. I'll have to email John and see what we can do. But I think we can go on at least for some of these. I don't want to get maybe too far. but we'll see what we can do here. So install and solder the side tone level 500 ohm pot, which is marked 501, and it is, so this is the next piece here. And it's R31. Let's look at our picture here. It's right here next to our power jack, the missing power jack. That's not the end of the world. Like I said, this kit has been super well organized so far, and maybe we'll find it. Maybe I lost it somewhere, but I know he's been inundated with orders. Actually, there are no more of these kits. So if you're wanting to build one, I hope you got it. Got your order in and you got one on the way to you, because he said he's out. They're out of stock. I think he said he's checking his inventory to see if he can build anything else. But I'm pretty sure that he said there were no more of these. So let's, oh, I don't want to do that. Let's look at our handiwork here. Yep. We gotta trim these guys. I'll take this off camera so I can get them in the trash can. Alright. That's step 5. I'm gonna mark these off so that I know we didn't do step 4. So we did 1, we did 2, got 3, and we got 5. So we're missing step 4. Alright, so now we're going to step 6 is the PA bias pot, which is R40, and low battery warning pot R46. They're both marked 502. Those are 40 and 46. So here's our 40 and our 46. See, he's right next door. Next door neighbors here. Make sure they're pushed in there real good. I want those to be nice and flush. Alright, so solder them up. So there's our 6 potentiometers leads there. Let's check those guys out. I think I want to get a little bit more solder on this guy. There we go, that looks better. Alright, I'm going to get off camera again here for a second just to clip these off. Said when I started this project I was going to get some more side cutters or flush cutters there because these are getting dull. I never did that, so they're still dull. Go figure. Alright, so now we need Q18, which is one of our FETs here. So it's BS170. These were really hard to get for a while. It's interesting. Empty bag. The QCX and QMX and all those use these same transistors, and I blew up some of mine, and it was very difficult to find for a while. Turn this light up a little bit. Make sure I got the right thing here. Got BS170. Alright, so place the flat side on the part overlay, and you want about a quarter length of lead sticking above the board. So let's see if we can find Q18 here. Let's get our trusty diagram out. Let's see. Q18 is right there. Okay, we want about a quarter inch of lead above the board, which is pretty much right where the little bend is. So let's do that. Shouldn't have started this tonight. It's like 9 o'clock at night. I've been working today and I'm kind of fumbling stuff around. I may make this a short one, especially since we are missing a part. I'm going to have to email support and see if I can get another one sent out. Alright, so let's look at our other side here. Make sure, yep, we got about a quarter inch of lead sticking up, which is what we wanted. Inspect our joints. That looks good. So now let's just clip this guy here. Yeah, these these clippers have definitely seen better days. Tools like this tend to be used for purposes that they are not intended for. And then they get chips out of them. Maybe step away for a second here. You get chips out of the jaws and get dull, and there's all kinds of problems. Hard to keep good tools. These, like I said, are cheap Harbor Freight ones. I would recommend, if you want some good ones, get the, oh, I got a short there. There we go. Get the Exolite brand, which you can find just about anywhere. Amazon has them. Touch those up a bit. Pretty much any tool shop has them. I don't know about home improvement stores, but they last a really long time and they do a really good job. Alright, so we got our Q18 done. Let's gotta find what I did with my ink pen. Here's a pencil. I don't think this has any lead though, but let's see if we can mark this off. There we go. Oh, here's my pen. So now we're going to do Q6 the same way. And whatever that we just did, Q18 had a red mark on the holder here, just as an added touch. This one has a blue mark. Again, this kit is so well organized. That's really why I'm shocked that there's a missing connector, because everything has just been flawless so far. Very well organized with the, like I said, the parts here marked. 2 transistors, you could easily get confused. But this is a, let's see here, this is a 1N50C compared to the BS170 that we had on the other one. Alright, and this guy is Q6. So Q6. Let's bring our, it's over here. And if you notice, it'll be kind of hard to see. Actually, let me just do this. You'll notice the screen printing, there's an angle on one side and then it's flat on the other. So you want to make sure when you put the transistor in, you'll notice that it's round on the back and there's a flat side. So the flat side is going to actually go toward the flat side on the screen printing. And this one we're going to do the same as the previous. We're going to leave about 1/4 inch of it sticking up. And then we're going to solder them into place. I need to print some more jaws for these. I melted them with the heat gun, trying to, I forget what I was doing actually. That's the nice thing about these stick vise, this 3D printed jaws, is you can print them in whatever configuration you want. You need to hold some odd shaped parts, you could print for that. And if you mess them up like I did, you can just undo it, just reprint you some more. One thing I would do over these screws, or these springs here I got, are incredibly stiff. It's really hard to compress the 2 ends together when you want to release the board. So I would probably, and I may look for some lighter tension ones at some point in the future, just to make it a little easier. Alright, so let's mark off Q6. Alright, so now we've got some electrolytic capacitors, so this should go pretty quickly. We've got 6 of them. 1, 2, 3, 4, 5, 6. But I've been checking the values of all of this stuff as I go, which is important. As we showed here, I'm missing a component, so you always want to make sure, no matter how good a kit is, that everything is exactly as you have the right part values. 3, so we have 6 of them. 1, 2, 3, 4, 5, 6, and these should all be 100 microfarad. So let's check all these guys. So that's 100. Turn the light up on this camera a little bit, it's kind of dark. There we go. Alright, so 100 microfarad. 100 microfarad. 100 microfarad. And last one, let's see. There we go, 100. Alright. So I think what I may do is try to position all these through the board and then solder them all at once. So we've got C49, and before I do this, one thing I mentioned in a past video is these electrolytic capacitors are polarized. So there's a positive side and a negative side. You can see here there's a stripe, so this is the negative side, so you want to make sure and pay attention to that when you're putting them into the board. And in his case, the long lead, the positive lead, so again you can see there's a long and a short, and the negative stripe goes to the short. So the long positive lead goes towards the square pad. Alright, so C49 is going to be our first one. Might be easier to find on our picture. Okay, so he should be here. And let's see, I think the square hole is towards the bottom. Yep. So we want our positive one to go towards the bottom. And this needs to be tight against the board. But two of these are going to be laid flat. So we'll want to make sure that we do that correctly. So C77 is one of the ones we're going to bend over, and he is up here at the top. Square is towards the top. So let's take our long lead, put him towards the top, and then we want to lay him over before we solder it. I'm just bending his leads back on the back side of the board to hold him in place. And C78 is also going to be one that we lay down, which is right there, and the square hole is to the right. Our long lead is going to go to the right. And we're going to lay him down. Make sure we get him in there far enough. We don't want him to interfere with our connections there. There we go. Okay, so C79. It's right by the call sign there on the board. We can find that here. Okay, the square hole is going to be to the left. C80 is over here, and I can tell by looking at this one the square hole is at the top, and actually I can see the plus. Some of these, there's a plus on the board too. You can see it kind of to the upper right there. Some of them are kind of covered up, so just want to make sure and get our positive side that way. And then our last one, which is C83, which I think I see on the board, but C83, that's C53. I'm glad I didn't just put it there. So C83 is up here in the upper left-hand corner, and the square is towards the top. Our positive lead goes towards the top. And that's all of those. So let's flip this guy over. This is giving me such a fit today. Alright, so let's see, this is one of our straight up and down guys, so I'm gonna just get him started. Maybe. Start on this square one then. No, it did not work at all. This guy is just being obstinate here. I think I got it. The board's not wanting to heat up. I can get the solder to flow onto the leads. That went great, but let's go ahead and clip these off, and then we'll try to touch up our solder joints. And then we will come back and finish clipping those guys off. Let's see if we can get this heat down into that pad. It's heating up the leads, but the board itself just not wanting to flow for some reason. Not a big fan of that, but I'm not sure what else to do. I don't have a flux pen, unfortunately, at the moment, because that could potentially help. Let's see if we have any trouble with any of these other ones here. Go ahead and try to get them all somewhat attached here. That one seemed like it soldered really nicely. Alright, I'm going to trim all these leads here. I'll be right back with you. Alright, let's see what we can do about getting these to flow a little better. Alright, let's look at them under the scope and see what we have here. Okay, well, I actually did get, yeah, they look better than I thought they did. There it is. Okay, so let's go ahead and clip those off. Alright, I think we got that cleaned up. Let's go ahead and do the fun part and mark this off here. And I think what I may do, actually I'm going to finish these capacitors. These should both be 247 microfarad. I think since I'm kind of shaky and I'm missing some parts, I need to email John while I'm thinking about it. I'm going to put these two parts on and then we're going to call it a night. And I think we're about halfway through. C53 and 91. So I think we're about halfway through with this board anyway, so that's a good place to stop. What, 53 and 91. So 53 and 91. And again, we want our long lead to go through the square hole. And positive lead through the square hole, so you can look at the long lead or the stripe. The stripe will go in the circle hole. Alright. So maybe these will go a little better than the last batch did. Not look like it. We just need to get the board good and hot. You can see a lot of ground plane here. All these big solid areas, and they're stitched together with a lot of vias, so it'll take a lot to heat up. So it's probably what's going on. Yeah, see, this is what I need to call it. My hands are not wanting to cooperate with me. Alright, so let's cut these leads because they're kind of in the way. Try to get to this guy before the board cools off too much. Yeah, see how much easier it melts when the board's got some heat in it. Alright, and we'll remove these leads just to help remove a little more thermal mass there. This is one of the reasons it's really important to have a regulated iron though, because if you have a regular, just a straight up like Radio Shack resistive, 50-watt iron, once you put it in the board like this, it just sucks all the heat right out of it. With the regulated one, it will keep heating up and try to keep the tip at the temperature it's set to. And it really helps with situations like this where you have to dump a lot of heat into the board. Alright, let's clip these guys off. Alright, and let's see what it looks like here under the scope. Not too bad. Alright, so let's mark that off and then we'll go ahead and call it done for now. So we have steps 11 through, what do we got? 19. So we have 9 more steps to go, plus step 4, which we couldn't finish because I'm missing the jack. So I'm going to email WA3RNC and see if I can get a replacement jack on the way. But there we go. We're about halfway done with the lower board, which makes us about 3/4 of the way done with the whole project. So thanks for coming along with me and building along if you are, and until next time, 73.